Okay, students, now comes question number 14, and it's about solving the trigonometric equation, which is given by 2 cos squared x plus 3 cos x plus 1 equals 0 on the interval 0 to 2 pi. This basically is on the interval 0 to 360 degree, because the radian measure for 2 pi is 3, the degree measure for radian measure 2 pi is 360 degree. So within the range of 0 to 2 pi, or within the range of 0 to 360 degree, we are looking for now the value of x that can satisfy this. So to obtain this one, what we need to do is the following. Okay, so look, 2 cos squared x plus 3 cos x plus 1 equals 0 is basically a quadratic equation written in terms of cos x. So we need to look for, you see, two numbers where their sum can be positive 3 and product 2, because 2 times 1 is 2. So as you are thinking of these two numbers, the numbers are 2 and 1. So in place of 3 have, as you see here, 2 and 1, because the sum of 2 and 1 makes 3, as you see. The product of 2 and 1 makes the product here, 2 times 1, which actually is 2. So in order to factorize this, we have to think in such a way. Now if you observe the first two terms, you see these two terms possess cos x as a common term, so 2 cos x as a common term, so let you take 2 cos x as a common one. So as we're dividing 2 cos squared by 2 cos x, 1 cos x is remaining. Here 2 cos x divided by 2 cos x is 1, so cos x plus 1 can come. Here also we are having cos x plus 1. Look, cos x plus 1 is repeated twice, so we can take 1 cos x plus 1 as a common out. And cos x plus 1 into 2 cos x plus 1 equals 0 can come. So dear students, as you see here, the product of two expressions are happening here, being 0. So either the first one or the second must be 0. So when we consider the first one, we have cos x plus 1 equals 0. And moving this plus 1 to the right, we do have cos x equals minus 1. So think of x values within the interval 0 to pi that can make minus 1. And obviously, as you all know, it is pi that makes cosine of pi that makes minus 1. So one possible value for cos x to be minus 1 is pi. So we can have one value here, pi. And when we come to the second case, the case where 2 cos x plus 1 equals 0, what you need to do is you have to move this 1 to the right, and it will be negative 1. So dividing both sides by 2, cos x is going to be negative 1 over 2. So the value of x that makes this to be satisfied within the interval 0 to 2 pi, or 2 pi over 3 and 4 pi over 3, because you have to consider 120 degree and 240 degree, because 120 and 240 will enable us to have their cosine values to be negative 1 over 2. So the corresponding radian measures are 2 pi over 3 and 4 pi over 3. Thus, all possible values that can satisfy this within an interval of 0 to 2 pi are 2 pi over 3, 4 pi over 3, and pi. These are, you see, the possible three values that can satisfy our trigonometric equation within the interval 0 to 360 degree or 0 to 2 pi. Okay, now up next is next one, which is question number 15, and it says what remainder do you get when we divide x to the power of 999 minus 2x to the power of 19 plus 3x squared minus x minus 1 by x plus 1. So dear beloved ones, I hope here you will never start dividing this long polynomial by x plus 1, because if you do so, it will be time taking, tedious, so it's awkwardness to do this question by using this approach. So what you need to do is you have to go apply the concept of remainder theorem. And as you know, remainder theorem says the following one: take the 0 of x plus 1. The 0 of x plus 1 is minus 1. Right? So the 0 of this x plus 1 is minus 1, so you need to substitute minus 1 in place of x throughout here. And the resulting one is nothing but it is a remainder, okay? So the remainder is going to be minus 1 to the power of 999, as you see, minus 2 times minus 1 to the power of 19 plus 3 times minus 1 squared, minus, have minus again 1 again here in place of x, then minus 1. So when you simplify this, what's going to come here is the following, okay? Minus 1, the power of odd makes minus 1. You see, no need to worry about this one. Whenever the exponent comes even, it will be positive 1. But for the time being, it's odd, so it will be negative 1 here. Minus 1, the power of odd, again, 19 is odd number, so it will be minus 1 times minus 2, positive 2 can come. Here minus 1 squared is used, it's even, so it's positive 1, 1 times 3 is 3, then negative makes what? Positive 1, and then minus 1 comes outside. So this makes minus 1 plus 2 is 1, 1 and 3, 4, 4 with 1 is 5, 5 minus 1 is 4. So no need of carrying out that long division technique, just using remainder theorem. One can easily obtain that the remainder is for this is going to be 4, you see? The remainder is 4. And next from this we have another question, and it says find a polynomial having roots 4, 0, minus 3 and minus 2, having multiplicities 2, 3, 2 and 1 respectively, and having remainder 54 when it is divided by x minus 1. So what you need to do is, you see, the solution goes like this. The polynomial will have this kind of form, you see. The zeros are already listed here. 4, if 4 is a 0 for the polynomial, x minus 4 is a factor, and this is assured by using factor theorem. So you may take x minus 4 here. Since you have been told that, you see, 2 is its multiplicity, you need to have 2 as exponent here. Here also we are having 0, so x minus 0 is, you see, the factor, which actually is x. And again, for this, we have been told that 3 is its what? Multiplicity, so you need to have 3 here. Here also, minus 3 is one of its roots, so x minus 3, which actually is x plus 3 is a factor. And for this, again, you have been told that 2 is its multiplicity, so you need to take the exponent 2 here as because of this multiplicity. And minus 2 is also another root, so x plus 2 is going to be what? Possible factor. And here we are having multiplicity 1, so you can have 1 here, or you can omit it if you want, no problem, because it's understood that even though 1 is not written, you see, x plus 1 is understood, it's understood that it's appearing here. So now p of x is going to be k of x minus 4 squared x cubed k plus x plus 3 is a whole squared x plus to the power of 1. So this polynomial basically is obtained from this one. Here we need to use, you see, a certain constant k, because we don't know, you see the multiplier here, we don't know that. But in order to determine this k, we must have extra information, and that has been stated here. We have been told that, you see, the remainder is 54 when we divide the polynomial by x minus 1. So again, here we need to use concept of what? Remainder theorem. So when we put the 0 of x minus 1, which actually is 1 here, when we put 1 here, where in place of x in your p, you must have a remainder, you must have a number which is equivalent to 54, because the remainder theorem says so. So let's substitute now 1 in place of x. So when we put 1 in place of x, what's going to happen is 1 minus 4 the whole squared, as you see it is here, 1 cubed, and 1 plus 3 the whole squared, and 1 plus 2 the power of 1. 1 minus 4 is basically minus 3 squared, 9 can come, and here 1 plus 3 is 16, 4 squared 16, and we here are having 3 times 16, 48. 48 times 1, 48, and 48 times 9 times k is going to come, as you see. Since we have been told that the remainder is 54 when the polynomial is divided by x minus 1, we have to equate this with 54. You see, student, here 48 times 9 times k is equal to 54. So from this we can determine k. So how do you determine the value of k? K is nothing but it is equivalent to 254 over 48 times 9. We know that by 9 it is 1, by 9 it is 6, by 6 1, by 6 8, so k will have a value 1 over 8. So once we obtain k value, we directly substitute this 1 over 8 in place of k, because our intention is to determine the polynomial, right? You are asked to determine the polynomial, so now the value of k is already determined. So we simply copy 1 over 8 and paste here, so that the polynomial can easily be determined, okay? Hence, The polynomial is p of x, which is given by 1 over 8 into x minus 4 squared, x cubed, x plus 3 is a whole squared, times x plus 2. Here is a polynomial, okay?